Good morning. I'm Professor Magin, and I have the pleasure today of speaking with Professor Tejal Desai. And Tejal is one of the first hires that I was involved with when I came to the University of Illinois at Chicago back in 1999. And at that time, we were rebuilding the department, and I think perhaps it was a bridge too far, but we tried to rebuild everything. We rebuilt the curriculum, we rebuilt the research focus, and sort of we rebuilt the faculty and the physical structure. And so I'm looking forward to talking with Tejal about her memories of those times and also catching up with her on her career. She's now a professor at the University of California, San Francisco, and she'll be giving a seminar tomorrow at the university, and she's actually fit this interview into her schedule today because she's back advising and providing guidance on the future of the department still. So Tejal, welcome.
Thank you. It's actually great to be here.
Good. And I mean, thinking back, I remember you standing under one of the columns over here in Greektown as a what was it, 20 under 30 or 40 under 12 or something?
Almost.
It was a crane.
It was a crane to go, yeah. 40 under 40.
40 under 40, yeah. And I'd love to be under 40 again. But
Me too.
those were busy times for me, and I know they were busy for you. Can you think of any challenges or any perspectives that you'd like to share?
Sure. Yeah, I mean, so I was, as Richard mentioned, one of the first faculty hires in this reimagined department here at UIC. And I still look back at those years very fondly because I think in terms of my career, they were probably one of the most sort of pivotal, influential years of my life as a bioengineer. And part of that was really embarking on this exciting prospect of building a new department. And as Richard mentioned, really having the latitude to imagine what an undergraduate and a graduate curriculum would be, how we would go and teach both didactic but also hands-on learning in bioengineering. And then maybe more importantly, really being part of this, it was almost a startup where there were initially the three of us.
It was John and Jay.
Jay and myself, and then Richard, and having really just this community with a shared vision and a goal to make this the best bioengineering department that we could. So I think those years taught me so much that I've really taken forward in my career.
Yeah, I had come from Urbana, and I sort of made the mistake of complaining that they did not have a department. And so the dean here at the time, Larry Kennedy, said, well, we're trying to get our department reestablished. And heretofore, it had been sort of a hyphenated department: biomechanics, bioinstrumentation, and sort of bioimaging, and where the bioengineering was viewed as if not an add-on, an adjunct to an engineering discipline. And Tejal and Jay Liang and John Hetling and I didn't look at it that way. We looked at bioengineering as sort of a holistic, new discipline that required, as Tejal mentioned, new ways of teaching, new ways of doing research that integrated the biological, physiological, mathematical, and engineering all together. And thinking back, you're right, I think we were awfully ambitious in trying to do it all. And remembering our struggles with Whitaker and with accreditation and with other departments, it certainly, there were some battles we won and some battles we didn't win. And I can see where maybe it helped you go forward.
It definitely did.
What parts of your research as they were connected with the medical school, because this is something now the department is actually jointly located and governed by the College of Medicine and the College of Engineering, which is something we tried to be co-located. We tried to get space over there.
But
I was never so bold as to think we should be part of it, but lack of vision, I guess.
Well, no, in fact, I think you had the vision, which is why, I remember
We had an acronym, didn't we have an acronym?
We did, and
David Carney was involved in it. It was core or coast or clan.
It was clinical.
Yeah, climb. It was
climb. In fact, it was the climb.
Laboratory for
Exactly.
Integrated,
Yes,
biomedical
engineering.
sure.
Right.
Okay,
Yeah.
Some
So
schoolwork up there.
I think we were just ahead of the time, right?
I'd like to think that. Yeah.
No, but it was actually one of the reasons that I was really excited about coming to UIC was the fact that the medical campus was right there, and the potential to think about linking bioengineering with translation and the basic medical sciences was something that it was sort of embraced here, even if it wasn't sort of set up.
Well, you found some kindred spirits.
And
with Brenda Russell
with Brenda, and we're still,
Still
we've
collaborating.
Right. We've had a grant together for almost, 18 years now. So
And I was always happy because it seemed like pharmacy, dentistry, medicine, all of the allied health professions, kinesiology, public health, they were, even nursing, were warmly supportive of bioengineering. And so I didn't look so much to our engineering departments within our college although you did do a lot of work in the microfabrication facility, or not.
Think about that.
But I tried to look west, and I think looking west was the proper way, and I'm happy to see that the department continues to move in that direction. And I'm happy to see in your work you're still working with surfaces, with cells,
exactly,
with engineering concepts, but trying to mold tissue into maybe the image of the things that you can nanofabricate.
Yeah, I think so. One thing I think that I learned that was very valuable is this notion of collaborating across disciplines and making those connections to the West Side, which now I look at my department and we're sort of integrated between medicine and pharmacy and engineering at Berkeley, and I think it was sort of a natural connection for us to think that engineers could be, working with all of these allied health professions, and that certainly came from my time at UIC.
And I think the bioengineers often are that fulcrum that balances the translation, because often we are asked to communicate and to cooperate, because on one hand we know maybe the expertise that is available on both sides, and whereas the individuals that have that expertise are probably often too busy to actually go looking for help.
You got it.
But I'm happy to see that you're continuing to do that. And I was talking just recently with Hann Ballesteros, who's a targeted drug delivery person, as you know, and she was talking about how her focus right now is on trying to ensure that what she has done is translated. She said she's spent many years successfully being funded with grants and projects to develop new concepts, but then they reach this stage where their wings don't quite support their weight so they can fly into the clinic. And I wondered, are these issues that you struggle with in your research, and how do you approach?
No, I think it's definitely I wouldn't say a struggle, but maybe it's both a challenge and opportunity. In that, I think one of the reasons I went from UIC to BU, Boston University, where I was in a college of engineering, and then I reached a point in my research where I really wanted to think about moving it out of the lab and into a place, either into the clinic or into commercialization, and really get to patients. And so part of going to UCSF allowed me to also make those connections and really say, hey, what does it take to develop a technology, whether it's a nanotechnology or a MEMS device or a biomaterial, that makes it from the laboratory all the way to scale up, manufacturing, FDA, and eventually back into the clinic. And those were issues certainly I wasn't thinking about early on, but as our research matured, really for me now thinking about how do I want to make an impact, it's, well, I want to get my stuff out there. I want to actually help people.
That's, yeah, I think a common theme, and I think it is one of maturity. You want to see the relevance, but you not just for PR, but just for helping people. And you know, Hyatt said she gets a lot of letters and inquiries from patients or doctors who want access to this technology. And do you see a lot of that coming in?
Definitely.
Because we try to promote what we're doing by being, you know, public faces for our research, but with that comes the responsibility of answering the public about our work.
Yeah, and I think there's a profound responsibility because we are developing technologies, but I think if someone just reads about it in a press release or a paper, they think it's, you know, going to be here tomorrow. And you know, we really have to think about, you know, how long is that going to take, and being realistic to those people who contact me. And I can say these are the things we know are near term. These are the things that we're working towards. But I think seeing a patient perspective on how important what you're doing is really important.
Yeah, I think there's still a lot of work to do.
Yeah,
to
I mean, we were, as you know, we started out in sort of the diabetes area in sort of developing cell transplantation devices, and we actually took a hiatus from there because I felt like we weren't making the sort of progress that I wanted. But sort of going back to, you know, coming to UCSF and really hearing from the patients that we're still really, you know, need this type of technology, and it hasn't been solved. And you know, is there a way that with all the advances that have recently been made, we can bring that back? You know, it's really reinvigorated me to sort of go back into that area.
Because I know Dr. Oberheiser here is doing.
In fact, we work with him as well.
Right, and yeah, it's interesting because we teach and promote ideas within tissue engineering. But then when we look at the actual practice, it's often a step below sort of the elegant, engineered surface that is that has the perfect, you know, set of properties. But it's hard to you know, introduce these things without being concerned about safety and efficacy and all of those aspects of it. Yeah, I'm glad to see you're still working with that.
No, it's interesting. Yeah.
And you talked about how your work has progressed. Well, when you were first thinking about coming into this field, were there individuals or situations that helped guide you in? I know at one time you were very interested in writing. And you probably still are.
I have no time for it, but
I wondered, you know, how did you get how was your education and your mentoring shaping you toward the career you're in versus maybe James Smiley or?
I was always interested in a lot of different things. You know, everything from writing to political science to engineering and medicine. And I think what I realized is that bioengineering could really serve as a platform to do a lot of that. You have to write more than you have to do right, but I think from a sort of also from the perspective of it's a wonderful major to and sort of area to see many different perspectives and bring those into your own work. And so, I think I was definitely swayed by some of my professors who said, if you pursued an academic route, you could do your science, but you could also, work in public schools and help children with science.
And
you can
I
also,
know you did when you were here.
yeah,
you went
yeah.
out to high schools and gave talks. And,
you could also work on science
provide the
policy
role model,
issues,
right.
and so I feel like part of it is bioengineering was an exciting area, but also it gave me a way to pursue a lot of these other interests at the same time.
Are you still writing in your spare time, or thinking of writing? Or?
Thinking about writing, not as much as I think I write for fun, but I haven't done anything formal. Aside from grants.
Right. Yeah, I remember you spoiled me on a couple occasions because I would ask for part of a proposal or part of a report, and most people would nod their head. And in a week or so, I'd remind them again that they were supposed to do that. And you always had it on my desk the next day. It was written better than I would have, deemed it necessary. But yeah, I think that's a facility that I try to encourage in my students. I'm asking them to write papers, and we have a student journal, research journal, that tries to encourage them to
and
learn.
I think I remember you starting that as a vehicle for some of these students.
And I wasn't the world's best communicator or the best writer, but it's become clear that you have to be able to express yourself in order to have your ideas not just accepted, but funded, or promoted, or yourself promoted in some cases if you can't do this. So where do you see your work and the discipline of bioengineering going in the future? I mean, you were present at the creation when we established it in the form that we have now, and there are something like almost 100 departments of bioengineering around the country and world. Do you see it continuing to grow, spread, or?
That's a great question. I think we talk about this all the time in terms of the discipline of bioengineering, and are we teaching our students the right things they need to know to go out? I still believe we produce wonderful students who can do so many different things. But in terms of the research around bioengineering, I guess from my own work, what we're discovering is that this notion of engineering in situ, or really taking advantage of the biology that is already present in our body and being able to intervene or sort of be able to manipulate that biology by either engineered structures or materials or delivery approaches.
Sort of working with the body.
Working with the body as opposed to try to be against the body.
Right.
And so, I think an example of an area that certainly is growing within the therapeutic discipline is immunotherapy, really trying to design materials that will specifically activate the immune system in a way that makes it want to attack a tumor or want to attack an autoimmune disease, as opposed to sort of decoupling what's happening in the body with whatever engineered material that we design. So, I think increasingly that's going to pose some challenges in that we have to be as conversant in the biology and the immunology as we are in the engineering and the device and the design. And whether that's really possible, certainly at the undergraduate level, is debatable.
That's always the struggle. Engineers work at the interface between science and technology, and I often have noted that when things can melt down, burn down, fall down, you need an engineer.
You do.
And I think with biomedical devices and medical products evolving, the regulation, the certification, the improvements of all this technology falls to the engineer.
Yeah.
And I think you're absolutely right. A bioengineer, it's an expanding palette of colors that they have to be able to use to design the new devices. And I think we started out not trying to be a subset of a mechanical or an electrical engineer by sort of inclination.
Right.
But I think by experience, it's been clear that this is probably the proper way to go.
And it's I think actually being in a sort of health sciences environment has made me appreciate more my background in bioengineering, because we really do bring a unique perspective and skill set, and many of the people come to us to help solve their problems. I think they could go to a mechanical engineer or an electrical engineer or to someone else, but I think when they come to a bioengineer, we both understand what can be done from the engineering perspective, but also what's practical in the biologic context.
It's sort of an impedance matching.
Exactly.
Where you couple, and you can't do everything, but
right.
you
but
probably
we
have a better idea
exactly
than they do about what can be done.
What can be done and what will potentially work. So.
And I've always been impressed by our students, because they come in better and better prepared, and they always amaze me with the kinds of questions and the kind of solutions that they come up with. And so I feel challenged to try to keep up by developing better ways of teaching, better ways of motivating.
Right.
More and more I feel like a coach as opposed to an
And I think
instructor.
that's it, right?
It's the old metaphor.
So motivating them to really
you're not
take control
filling
of
a
their
vessel, but you're igniting
Yes.
enthusiasm. And this is what I think we see with a lot of activities. If students are interested in something, then they'll spend whatever time it takes to solve the problem or to learn about it to their satisfaction.
Yeah.
If you're just telling them to study this so that you can do the times 7 table, well, they're going to stop it. The
times
table.
seven. No.
They're not going to think about other bases or other ways
Yeah.
of doing it. Are there words of wisdom you might provide for students seeking out this discipline versus another discipline? One criticism I hear of bioengineering is, well, it's great for a PhD or an MD PhD, but I'm working on my BS, and what job will I have? What role can I have in this exciting future that you're articulating?
So I actually think that there is a future for undergraduate bioengineers. I think we have to define what it means to be successful in that field, because many of the bioengineering students are some of the best students we have at that level, and they go on to become leaders. They may be leaders in many different arenas, but having that ability to solve problems, to work across boundaries, to integrate diverse perspectives is something that doesn't matter where you go in life. These are essential skills to bring.
Yeah, I came out of a physics department, and the physics department seemed to have the same philosophy. They didn't expect only card-carrying
to become a physicist.
They were happy if you wanted to go into finance or go into engineering even.
Exactly.
They felt that there were some that would go into physics, but that physics was a foundational discipline for many other areas of technology, and I think that's becoming more and more true.
And in fact, I agree.
And I think it's also a discipline that not only is it wide open in terms of what can be done in it, but it seems to embrace all perspectives, all genders, all capabilities. There's no restrictions on what you do to either being too much computer-driven or too much working with concrete or too much working with a structural model. You're expected to be much more flexible.
Yeah, and that's the sort of the flexibility and the trait of being flexible and adaptable. Again, I think it's an important trait, no matter where you go with that. The other thing that's one of the benefits of bioengineering is that because of that mission to help people, it really is able to attract that diverse set of students from many different backgrounds.
Yeah, I just saw the statistic on the Department of Bioengineering, which started in Urbana after I think there were 3 of us that left to head departments at Michigan, Illinois, and I think maybe Florida, that finally they formed their own department, but they pointed out that their freshman class this year is now 52% female.
Yeah, which is amazing.
Right, and that's not...
It's the only engineering discipline that can say that.
Right, and I think it's, and here our students are traditionally the best students in the college.
Yeah.
And the college is quite good within the university. So I think there are challenges for the students
Right.
to work in this group. But the curriculum, as you started developing it and as it has grown, now provides opportunities at the freshman, sophomore, junior level with clinical immersion, opportunities to work with our colleagues on the West Campus, opportunities to begin to see what it takes to make a biomedical product succeed as opposed to something better, faster, cheaper. It has to be safer and more effective, and it has to be integrated into the current practice in a seamless way. So
I couldn't agree with you more.
I think our students are taking up those challenges. At least I feel like that.
Yeah, and I have to say, the students that I had at UIC were some of the most creative, most resourceful, resilient students, and they've gone on to be really tremendous scientists and engineers.
Oh, yeah, I remember recruiting Dave Silva when you were here, and he's now a professor.
He's a
at
professor,
UCSD,
right?
and,
Exactly.
And there's a whole host
I
of
think
others.
3 out of 4 of my students from here went on to academic positions. So
that's good.
Interesting.
And I think, to our credit, some of these students recognize the opportunities that we were providing. It wasn't within a discipline, you can take a course in instrumentation or a course in imaging, and we'll sort of retrain you in a higher sense as a bioengineer. We were trying to get
here's
into,
the discipline.
Right. And I think by focusing on bioinformatics and neural engineering and tissue engineering, we sort of drew that line in the sand. And I think the bioinformatics now we're actually developing it, I think, at the undergraduate level. This is the one thing I didn't do was when we proposed the new program in bioinformatics, there was a box you checked for BS, MS, PhD, and I just felt like
too much already.
Exactly. I didn't realize you could check the box
and not do it.
And so I didn't check the box. just want to go back and check it. So now we have to go through the whole Illinois Board of Higher Education.
Again, that was, an area with, you had a lot of foresight to have envisioned. Now bioinformatics is so integral to, actually how we treat patients, right? Precision medicine and medical informatics are part of care.
Yeah, there was a good article in the New York Times this week about some new vaccines that they're trying to develop for treating cancer, and they're trying to basically just change the paradigm from something you cut out or burn out to something that becomes a chronic condition that you can treat by because the problem is getting the immune cells that take care of the few cells that escape that are metastatic. If you can control them, then you often can live a normal lifespan. But it isn't, that isn't always the way we looked at it. But I think, so I'm happy to see that you're working in targeted drug therapy. As I get older, I'm running into the wall sooner or later, and I want to make sure there's a door somewhere in that wall that I can go through, hopefully.
I hope for somebody.
So are there any final words of advice you might give someone starting out, either as a faculty member or as a student or as a...
Well, for faculty members, I think I've always been a big fan of embracing the opportunities that come to you, and not being afraid to sort of move in different directions, given your research, because I think some of those unintended collaborations ended up being really big new areas of research that I never would have dreamt that I would go into. So, definitely.
Looking back, I agree. I think I've seen of the faculty in your generation, many were successful, some were not, and often it was exactly that sticking too close to the, to the crop or the row that you're trying
Right.
to build further in one direction often became a hindrance because it kind of blinds you to other opportunities that you have to embrace. I got involved with them in MRI and elastography from students. They said, why can't we do this? Well, I admitted I don't know how to do it, but if you'll get started, I'll try to learn when I can.
Yeah.
And I guess that's worked for you.
Yeah, it's definitely, and trust your students, because I feel like the students have always been what has motivated me and what has really brought the energy and the new ideas. And so
right, because they will say, or they will check, because often you have an idea based on your experience, but things have changed.
Things have changed, exactly, and they're willing to take more risks, and I think that's a good thing. If we can encourage that, they don't have the sort of preconceived notions of, hey, that's not going to work. We've tried it before.
Right.
But things have changed, and there are new technologies. There's new things we know, and so maybe this time it will work.
Good. Yeah. Well, thank you again for
you.
joining with us. And I should offer you a Cubs hat.
I was going to say, I was rooting for them, so even though they destroyed our Giants. But
I've certainly enjoyed talking with you again. It's sort of reliving some of our memories of working together, and those were very good and successful days. And I'm sort of as a grandparent now, I'm happy to look at faculty that I hired who are now professors and having.
Well, I know. You asked the question about sort of people who shaped my life, and it was certainly you. Probably had one of the greatest influences in actually sticking with this career and trying to do as much as I can in this area.
Yeah, I found that sometimes I go to the RSNA, and not often, but sometimes I'll meet a student and they'll remind me that they told me that I
exactly.
And then I realize, gosh, I'm glad that it worked out for you, because it's important, I think, to try to find the niche or find the right encouragement for folks. It doesn't make any sense to tell everybody they're going to be something that is inconsistent with their interests or capabilities. And so and I think it's what a good teacher or a good mentor does. It's not just, sets a high bar and says jump,
right,
but decides whether it's the balance beam or the high jump that is the best.
Yeah, and every morning I was excited to get to work, super early because because it was exciting. It was we were going to build something every day, and we we're going to, really define the field.
Yeah, and I think that's something I'd like to see. I hope that our faculty are doing. I worry that we could become too specialized, and I think having a foot in the undergraduate and the graduate programs, having a foot in the lecture hall as well as the lab and the clinic, it gives you a sense of ownership, which is important to balance things out. Because if you just sort of put your nose to the grindstone and grind away on it, well, it's going to wear out eventually, and your enthusiasm for that will wane. And so I think it's important to develop sort of the all-court perspective. But I'm happy to see that you have developed and you're continuing to be successful, and I'm also like to thank you for coming back and sharing your expertise with us and helping us to look forward and plan our next steps here at UIC.
Wonderful.
So, thank you.
Thank you.